Once the fuel runs out, there is no more mission. You have to decommission. So the fuel is very important for the spacecraft. It can only last as long as the fuel.
Telescopes like NASA's Nancy Grace Roman Space Telescope move and point using two methods. There are reaction wheels to turn the spacecraft with precision and then hold it steady. And then there are thrusters that use propellant for large motions to push the spacecraft into its correct orbit and maintain that orbit. All which require fuel. Before entering the large clean room, the propulsion tanks were assembled in a smaller lab.
So right now we're looking at the propulsion system for the Roman Space Telescope. Today we put our last tank on the propulsion support frame. The propulsion support frame is the frame that's supporting everything.
The 4 tanks seen here were each carefully lifted individually. The deck that supports them gets positioned below that tank. These 4 tanks fuel a series of 24 thrusters with 2 different sizes.
On the sides, we have all of the engines. So we have 4 sets up top. Those are our upper ACS engines. We have 4 sets at the bottom. Those are our lower ACS engines. And then at the bottom over here, those big triangle pods, those are all of our Delta V engines. So those will do our big maneuvers.
With the tanks in position, they're ready for integration into the telescope's spacecraft bus, which happens in NASA's largest clean room. Now, thrusters use conservation of momentum. Ignited fuel creates expanding gas, which exits the engines in one direction, and the observatory moves in the opposite direction. The thrusters are so efficient in the vacuum of space that they can be surprisingly small to move the 18,000-pound spacecraft. This is all it needs. With the thrusters on the outside of Roman, the propellant tanks will sit within the observatory's central cylinder, close to their teammates, the reaction wheels. When the reaction wheels get to their maximum speed, they have to be slowed down again. The thrusters fire to balance that angular momentum change so that the spacecraft doesn't turn as the wheels slow. Since fuel is limited, it usually determines the lifespan of distant spacecraft. Luckily, the telescope can also point only using electricity. But how reaction wheels work, that's another story.